Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Hidden Sandwiches by Alaric Taki A, or Crusader 175, and here are the rules. Normal Sudoku rules apply, which means fill the entire grid with the digits 1 through 9 without repeats in any row, column, or box. We have fog, where the grid is partially covered in fog. Entering correct digits will clear the fog from the surrounding cells. So if you place the correct digit here, it would clear the fog in that cell and in the 8 surrounding cells around it. And that's how fog of war works. We also have sandwich layers, where the number in the top left corner of a cage indicates the sum of the digits sandwiched between 1 and 9 in that row, if it's a red cage, or in that column, if it's a blue cage, where a question mark can represent any sum ranging from 0 to 35. The digit in a cage indicates how many digits, including the crust of 1 and 9, the corresponding sandwich sum contains. So, this is similar to the regular sandwich rules, where basically a digit outside the grid would indicate the number of the sum of the digits in between the 1 and the 9 in that row or column. But instead, the digit is actually as marked next to a cage, or marked to a cage, where a red cage indicates the sum of the digits between 1 and 9 in that row, and the digit in the cage must be the number of digits, including the 1 and 9 of the sandwich, essentially. So it would be, as an example, say we had a 1 and a 9 here, and this added up 25 in between, right? So we could have, I don't even know, 6, 7, 8, and 4 in between. Then this would have to be a 6, and obviously we would have a contradiction here. So that wouldn't quite work exactly right. But you get the idea, right? This is 6 because it would have to include all the digits, the number of digits, including the 1 and 9 of the sandwich in the row. And this would then be 6 because if this were 1, 6, 7, 8, 4, 9. Anyways, that's how sandwich layers work, and those are all the rules. If you like to play along, there's going to be a link in the description. And now I'm going to get started. Let's go. Okay. So these cannot be 9. None of these can be 9 here. To have 25 in between the 1 and the 9, you have to have at least 4 digits, right? Because 3 digits by themselves, unique digits, can only add up to 21 because you cannot include the 9 in that, obviously. So this is at least 4. The maximum amount would be what, digits-wise? It could be 2, 3, 4, 5. If you try to have 2, 3, 4, 5, 6, 7, which would be 6 digits. Oh, you have to include the crusts. So the 1 and the 9. So that's 4 in between. You could have 5 in between, obviously. Can you have 6? That would require it to be at minimum 2, 3, 4, 5, 6, 7. And that does not work because that adds up to 27. So this is 6 or 7 here. This similarly must be 6 or 7. This 12. Hmm. This 12 can be two digits. It could be like something like 4 and 8 or 5 and 7. So that would be 4 total, including the crust. It could be 3 digits, 2, 3, and 4 works, but it cannot be 4 digits in between. So this is 4, 5. It couldn't be anyways because of the 6, 7 pair. So that would be problematic. Um, Can this actually be 6 digits? If this is 6 digits, that means there are 4 digits in between the 1 and 9, adding up to 25, but you cannot have a 6 with it. So you would have to have, at maximum, it would add up to 7 plus 8, which is 15, plus 5, and plus 4. That only adds up to 24, I believe, right? 7 and 8 adds up to 15, plus 5 is 20, plus 4 is 24. So this cannot be 6 here. This has to be 7. So this is 7, this is 6. Therefore, the crust has to have 5 digits in between the crust. So none of these can be crust here, right? If this were a crust, you could not have 5 in between here. So one of these two is a crust, one of these two is crust, but these can't be crusts here. For 6, any of these could be crusts because you have to have 4 in between. Any of these could be crusts, any of these could be crusts, so these cannot be crusts. We know there's a crust here, we know there's a crust here. So therefore the rest of the box cannot contain a crust because otherwise it would be too many. This cannot be crust and crust because it has to have at least 2 digits in between. So only one of these can be a crust. Therefore, this is a crust here, and these cannot be crust. So these can't be a crust now. This has to be 4 in between. Again, if this is 6, this has to be then 4, 5, 7, and 8 to add up to 24. This is a 1 or 9. This is a 1 or 9. Therefore, there's a crust here and there's a crust here. We're not sure which. This has to be a 2, 3 pair here outside. And it's 2, 3, and 6 outside, essentially. So one of these is a crust. One of these has to be a crust, so it could be 5 in between or 4. So this can't be a crust here. It's one of these two, it's one of these two. If it's 5, it has to be both of these. Hmm. Remaining digits here are 1, 4, 5, 8, and 9. Outside of the sandwich, so it has to be 5 in between. The outside of the sandwich has to add up to 10. Right? Because 35 minus 25, and in between 1 and 9 can be at most 35. 35 minus 25 is 10. So the ones outside has to be 7 and 3 specifically. Right? Because you have 5 digits in between the 1 and 9. Therefore, 3 cannot be here because of the 2, 3 pair, so this must be a 3 and must be outside. That's 3 in the corner. We celebrate because, I don't know, maybe we're going to get close to something solving soon. This cannot be a crust. It has to have 5 in between. So this is not 1 or 9. This is 1 or 9. This is 3. Either of these still could be in between. So if it's 2 digits, that would mean this is 4, so it would have to be 5 and 7 in between. It could be 5, 7 here or 5, 7 here. If it's 5 digits, that would mean there's 3 digits in between the sandwich. What are the possibilities? To add up to 12, it could be 2, 3, 7, 2, 4, 6. What are the other possibilities? 2, 3, 4, 5, but that would eliminate that cell here, so that's not possible. 2, 4, 2, 3, 7, 2, 4, 6. So if this is 4, this has to be 5 and 7. Or 5 and 7. Otherwise, if this is 5, this would be a crust. This would be a crust. These three would have to be... Could not be 2, 3, 7, because this can't be 2, 3, or 7. It could be 4 with 2 or 6 here. Can't be 2, 5, 5. And it can't be 3, 4, 5, because that would eliminate all cells there. So this would be 2 or 6 if that were the case. This could also be 1 or 9. So this can never be 8 here. This has to be, what, 2, 4, 5, 6, and 8. Does that add up to 25? It does. 2 and 8 add up to 10. 4 and 6 add up to 10. 5 adds up to 5. This cannot be 5. Either this is 1 or 9, and this is... Actually, it would have to be 5. If this is 4, this is 1 or 9, 5, 7, and 1 or 9. Or this is 1 or 9, this is 1 or 9, and this is 5, 7. So this can never be 5 here. This is 3. So 3 cannot be here. So since 3 cannot be any of these, where is the 3 in row 2? Can't be any of these 3, can't be any of these 3, can't be these 2, because you cannot have 2, 3, 7. You can't have 3 and 9 adding up to 12 for 2 digits, because the 9 has to be the crust. And you can't have 2, 3, 7. You can't have 3, 4, 5. So that doesn't work. So therefore, this is a 3 here. This is 3. This is a crust. This cannot be crust. So this has to be crust, and this has to be crust, which means this cannot be crust. This is 2 digits in between. Therefore, this is a sandwich of 4. This has to be 5 and 7 added together, so to add up to 12. So this is 5. This is 7. 7 cannot be here. 7 cannot be here. This is 1 and 9. This, therefore, has to be 2, 6, and 8, so that eliminates 2, 6, and 8 in the rest of the box. So this can't be 8. This can't be 8. There's an 8 here, which means none of these can be 8. Where is the 8 in box 1? It has to be here. So this is 8. This column, the crust can never be 2 for any, unless it's 0. Unless the value of the sum for the sandwich is 0. Cannot be 2. This can't be 2 or 6. So where is the 2 in row 1? It has to be here. So this is 2. 16. To add up to 16 for 2 digits is not possible, because you can only have 7 and 8 at most. So this cannot be 4. This cannot be 4. We have a 5, 6, 5, 6 pair, which eliminates 5 and 6 in the rest of box 2 and in the rest of row 1. So this can't be 5. This is 4. This can't be 4. These can't be 5. Um, if you had, so this must be either 3 digits in the sandwich or 4 digits. So none of these can be the crust. None of these can be the crust. The crust could be either of these. Um, huh. For 3 digits to add up to 16 or 17. Actually, let's look at 4 digits adding up to 16 or 17. For 4 digits adding up to 16, what are the possibilities? 2, 3, 5, 6. 2, 3, 4, 7, right? And then it would be 2, 3, 4, 8 for 4 digits adding up to 18. Or sorry, 17. 2, 3, 4, 8 add up to 17. 2, 3, 5, 7. So you could not have a 6 here if that's the case. Yeah. 2, 3, 4, 8 adds up to 17. 2, 3, 5, 7 adds up to 17. Two, 3, 4, 8, 2, 3, 5, 7. 2, 4, 5, 6 also adds up to 17. But that would eliminate all possibilities for that cell. So that wouldn't work. So 2, 3, 4, 8, 2, 3, 5, 7 so far. You cannot have 2, 3, 2, 4, 5, 6. And 2, 5, 6 already. 2, 5, 6, 7 adds up to 20. So that doesn't work. What about 3? 3, 4, 5, 6 as a minimum. 3, 4, 5, 6 obviously doesn't work because it eliminates all possibilities. Plus it adds up to 18, so that's not possible. So this can never be 6 then, because the 3 is always going to be outside the sandwich, right? This is not, so this has to be 5, which makes that a 6. So this is not a sandwich, therefore, sorry, a crust. This is a crust. So 4 digits adding up to 16. It's 2, 3, 4, 7. It cannot be 2, 3, 5, 6. It cannot have an 8, right? 8 would have to be with 2, 3, 4 minimum. And therefore that's 17. So this is not 8, this is 4, this is 8. We have a 4 guaranteed. I think it has to be, okay, 2, 3, 4, 7 adds up to 16. And you cannot have an 8 here. So you can't have 2, 3, 5 because it would have to be 2, 3, 5, and 6. If we tried to have 2, 4, 5, it would be with 5, and that's not allowed. So this is specifically 2, 3, and 7 remaining. This is 1 or 9. This has to be a 5, 8 pair here. This is 5 in between. So these cannot be crusts. Sorry, it's 5 total. So it's either crust here and crust here, or crust here and crust here. So these cannot be crusts because we already have a crust in the box, and one of these two must be crust. This is 5, 3, and 8 outside. What can be inside to add up to 17? It has to be 4, 6, and 7 adding up to 17. So 2 has to be outside. 2 cannot be here. Where is 2 in column? So 2 is not inside the sandwich. It has to be outside. It can't be here, any of these. So the 2 has to be outside here. And therefore, this must be not crust, and this is 2. This has to be crust, and this is crust. So this is what? This has to be 7. This has to be 4 and 6. Because this cannot be 7 here because of the 2, 3, 7 triplet in the box. This is 1 and 9. This is 1 and 9. This cannot be 4 here. Oh, it's column, right? Yeah. So this must be at least 5 in size. And it could be 6, right? But if it's 6, it requires 2, 3, 4, and 5, adding up to 14. And that can't work. So this must be 5 then. So this is 5. This is obviously not a crust. It's 3 in between. So this is 5, which makes this a 7, which makes this a 5. It's 3 in between, adding up to 14. Well, it can't be 2, 4, 8. Can it be any 8? No. Because it could be 3, 3, 8 if that's the case, but that doesn't work. So 8 cannot be in between. It's 3 digits, right? So you have to have 3 digits in between. Therefore, this can't be a crust because that would be 3 digits here, and that's not a crust. So this can't be crust. This has to be a crust. So it has to be in between these two. Therefore, these 2 digits add up to 9, right? It cannot be 5, 2, and 7. It must be 5, 3, and 6 then, right? To add up to 14. This is 1 and 9. This is 1 and 9. This can't be 6. This is 2 or 8, 2 or 8. This can't be 5. To add up to 22, you cannot have 3 digits by itself. Actually, yeah. So this is at least 6. Can it be 7? If it's 7, that's 5 digits adding up to 25. Sorry, 22. Is that possible? I think so, yeah. 2, 3, 4, 6, 8. Or 2, 3, sorry, 2, 3, 4, 5, 8. Or 2, 3, 4, 6, 7. So this is 6 or 7 here. So this is 1, 2, 3, 4 in between. And then we don't know about these, and these cannot be crusts. So since these can't be crusts, this could be crust, that could be crust. It must include a 5. So that means outside the sandwich has to be adding up to 35 minus 22, which is 13 here. So if this is 7, I think this has to be 6 then, right? If this is 7 in size, that means 5 digits are in between and 2 digits are outside. If this is 7, this is 6. Otherwise, this is 6. So either way, this is 6, which means this cannot be a 6 here in the box. So this must be 3, this must be 6. This cannot be 6 either. So this has to be a 6 here. If it's 6 outside, that means there are 3 digits adding up to 13. This is a 6, so the other 2 digits must add up to 7. Well, you can't have 1 6 6. You can't have 3 4 and 6. You can't have 2 5 and 6 because of the 3 and the 5 here. Therefore, this cannot be 6. This must be 7. This must be 6 then. And this has to be a crust, and this is not a crust. So none of these are crusts. Therefore, the crust is one of these. This is a question mark, so it could be any of these 3. So this could actually be 2. It could be 2 or 4 or 8. Can it be 8? No, because then that would be go off the grid. So it's specifically then the crust is here or the crust is here. The crust cannot be here. This has to be 2, 3, 4, and 8. Right? To add up to, with 5 to 22. This adds up to 17, so that's 5. And that's 22. Actually, this is neither. We don't know what this is. Okay, so this cannot be 2, 3, 4, 8 because of the 2, 3, 4, 8 quadruple in the box. Therefore, it has to be 1, 5, 7, and 9. And this can't be 1 or 9 here. So this is 5 or 7. This is 1 or 9. Remaining digits are 2, 4, and 8. 2, 4, and 8 here. And this can't be 2 because of that 2. This 5 eliminates that 5, so this must be an 8, which makes that a 5. These 3 digits are 3, 4, and 6 remaining. Remaining digits here are 1, 5, 8, and 9. This can't be 3, this can't be 6. Okay, what else do we have? Remaining digits in row 1 are 1, 2, 3, 5, 8, and 9, right? Well, we have a 1, 9, 1, 9 pair here in row 7, so none of these can be crusts. This cannot be 1 or 9. This can't be 3, so it's 2, 5, or 8 here. This can't be 5 or 8 because of the 5 or 8 in the row. This can't be 5 or 2. There are no crusts here because we have a 1, 9, 1, 9 pair there. One of these, this 6 means this can't be 6, so this is 4, which makes that a 6. 6 cannot be here, 6 cannot be here, 6 is one of these 2 digits here. This cannot be 4 because of this 4 here. Five has to be one of these 2 digits. 7 is one of these 2 digits. 3 is pretty limited. 4s. 5. 6. 7. 8 are very limited. Huh. Interesting. Um. Hmm. Okay. Hmm. Okay, we're gonna mark these as yellow, I guess. So this is yellow. This is red. This has to be yellow. This must be yellow. This is red. This must be yellow. This is red, which forces this to be yellow. Therefore, this is red. Yellow. Okay, there we go. So obviously these have to be different ones. So this is red, which makes that yellow, which makes that red, which makes that yellow, which makes that red. So yellow has to be one of these two, and this cannot be yellow because that has to be yellow. Because it cannot be here, it has to be this one. So this can't be yellow, therefore this is a yellow, which means this can't be 5 or 7. This has to be 5 or 7 here. So this is not the yellow one. Therefore, this sandwich is 4, which makes that 8, which makes that a 2. This sandwich is not next to the other one, so it cannot be one. Actually, a sandwich can't be 1 at all in size, so it has to be 9. So this is 9, which makes that a 1. This is 9, which means this has to be the full-length sandwich. So all the yellows are 9. All the reds are 1 now. So this can't be 1. This can't be 1. This can't be 9 anymore, and therefore it's not a crust. This 8 means this can't be 8, so this is a 3. That's 3 in the corner. We celebrate because we know we're getting close to solving it. This can't be 3. This can't be 9. So this is not a crust either. This can't be 9, any of these. Oops. So, and these can't be 1. Where's the 1 in column 4? It must be here. So this is 1 and a crust. These are not. These are not. 9 has to be one of these two. This can't be a crust either. So this is a 1. This is either size 5, which it cannot, or it could be, to add up to 20, or it's size 7. Well, if it's 7, these two would have to add up to 15? Okay, this can't be 1. So this is not a crust. Or that could be 9. So that's fine. This has to be the red crust. So it is a 1 here, which makes this a 7. Because the 7 can only be there. This can't be 3 because of that 3. So this is 4, which makes that a 6, which makes that a 3. This can't be 2. That leaves 5, 8, and 4 remaining. But this can't be 5 or 8 because of this 5, 8 here. So this must be 4, which means this can't be 4. This becomes a 5, 8 pair. This has to be 2, 6, and 9 here. But this cannot be 9 here. So 9's one of those two. Remaining digits in row 6 are 2, 3, 5, 7, 8. This cannot be 5 or 8, though. If this is 5 cells for the sandwich, that means 3 cells in between. This would have to be an 8. So it would have to be 6, 8, and 6, which is not allowed. So this can't be 5. This has to be 7, which makes this a 5. Therefore, outside the sandwich, which is 7 length, these two must add up to 35 minus 20, which is 15. So this is 8. This is 2. This is 5. This cannot be 7. This has to be the 9. So this is 9. This is 2. This can't be 2. This is the yellow, I guess, which forces this to be yellow. And these are crusts. So this is a 9. This is 6. This can't be 5 because of this 5. Therefore, this is 8, which makes this 5, which makes that 8. This can no longer be 8. This can't be 8 or 2. This can't be 2, so this is 3, which makes that a 4. This can't be 2. This can't be 3 here. Can't be 3 here. We have a 2, 7. This 5 means this can't be 5, so this is 8. We have a 2, 7, 2, 7 pair, which means you can't have 2 and 7 in the rest of the row, in row 6, so this must be 5. This has to be 2, 3, and 4 here. But this cannot be 4. Whereas the 4 in row 5, it has to be here. So this is 4. This 2, 3, 2, 3 pair eliminates 2 and 3 in the rest of column 3. So this can't be 2. This is 7, which makes that 2. Which makes that 3, which makes that 2. This 3 makes that a 7. This 2 makes this an 8, which makes that a 2. This 2 makes this a 3, which makes that a 2. This can't be 6, so it must be 3, and this must be 6. That's how you solve it. Yeah, pretty interesting actually. I could see this rule set having some legs. Um, Definitely some interesting dynamics between these this digit showing the size of the sandwich and the actual clue itself. Yep. Pretty interesting. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.